Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So we have problem 29, example 29 on resultant of concurrent non-coplanar forces. The square plate is suspended by four cables as shown. The tensile forces in cables AB and AC are 450 newtons, and those in cables AD and AE are 300 newtons. Determine the resultant force exerted by the cables on the support at point A. So in this problem, it is best to express each force into vector form. Then the resultant is simply the sum of the forces in vector form. Take note that AB and AC are equal in magnitude, 450 newtons. They only differ in the sign of the components, some components, but some components are also equal. For AE and AD also, they have the same magnitude of tensile force, so the components will be numerically equal for some. So for AB, it is magnitude of AB, which is 450, so A to B is directed downward, so negative along Z, zero point 0.8 meter, leftward, negative along Y, which is also zero point 0.8, then backward, negative also along X, zero point 0.7, so all components are negative. So FAB in vector form would be 450 over distance square root of 0.7 square plus zero point 0.8 square plus zero point 0.8 square times quantity negative 0.7i, negative 0.8j, negative 0.8k. So again, these are negatives, thus these values here, but we have even sign here because A to B is along Z downward, so negative 0.8k, along Y leftward, negative 0.8j, and along X backward, so negative 0.7i. FAB therefore is equal to negative 236.8i minus 270.6j minus 270.6k newtons. FAC is directed downward, so negative 0.8k, leftward negative 0.8j, forward positive 0.7i. So same form as this except that the X component is positive and the components are numerically equal. So FAC is positive 236.8i minus 270.6k minus 270.6k newtons. Next for FAD, it is 300 over square root of 0.7 square plus zero point 0.6 square plus zero point 0.8 square. Then it is directed downward, so along Z negative 0.8, rightward, so along Y positive 0.6, that one. Then forward, so along X positive 0.7. So in vector form, FAD is equal to 172.0i plus 147.5j minus 196.6k newtons. FAE is down along Z, negative 0.8, right, positive 0.6, backward, negative 0.7. So this is negative for FAE, negative 172i, still positive 147.5j, then still negative, negative 196.6k. So negative 172.0i plus 147.5j minus 196.6k newtons. Therefore, the resultant is the sum of these forces, and we add corresponding components. So FAB plus FAC plus FAD plus FAE. For the X component, negative, positive, so 0, positive, negative, so there's no X component. For J, negative 270.6 times 2 plus 147.5 times 2. So it is negative 246.2J. For K, negative 270.6 times 2, then negative 196.6 times 2. So negative 34.4K. Therefore, this is the resultant in vector form and in newtons. Then for your part, here is the problem. So same figure. The tensile forces in cables AB and AC are 600 newtons, and those in cables AD and EE 450 newtons. So determine the resultant force exerted by the cables on the support at point A. And this time replace 700, this 700 mm here by 500 mm, and the 800 mm long along CD, only this one, this remains 800 mm by 400. So that 400 plus 600 is 1000 mm, 500 plus 500 is 1000 mm. So it remains a square plate, and show that this is the resultant. So that's for your part. Verify that answer.